The day was October 14, 2017. A strange cosmic object was flying past our planet, and no one had the slightest clue. 5 days later, the interstellar object was on its way out of the solar system, when Robert Warwick, an astronomer at the University of Hawaii at Manoa, spotted it with the Panoramic Survey Telescope and Rapid Response System, PAN-STARRS. It was, from the moment of its discovery, a weird object, weird orbit, weird speed, and weird properties. The strange object was nomenclated Oumuamua, the first known interstellar object to visit the solar system. But here is the thing, astronomers had only 11 days to observe the odd visitor, as it was cruising out incredibly fast, 3 times the speed that Earth orbits the Sun. And then, it appeared too small and too dim to be detected. It left the solar system faster than it had entered, never to return again. And here is when it becomes really interesting. While tracking Oumuamua, we expected, perhaps naively, that it would follow a hyperbolic orbit, as though the only force acting on it would be gravitational. What we found, however, was that a normal, perfectly hyperbolic orbit didn't quite fit what we observed. It was as though there was an additional acceleration, as though something unobserved were pushing it, in addition to the influence of gravity. Tumbling through space at 90,000 kilometers per hour, the object is thought to have come from the direction of Vega, an alien star that resides 237 trillion kilometers away. Shaped like an elongated cigar, by the time it was spotted, it had already zipped by our own sun, performed a slick hairpin turn, and begun hurtling off in another direction. 2 things in particular fixated scientists. The first was its mysterious acceleration away from the sun, which was hard to reconcile with many ideas about what it might have been made of. The second was its peculiar shape. By some estimates, it was 10 times as long as it was wide. Before Oumuamua, the most elongated known space objects were 3 times longer than they were wide. Over the years that followed, scientific journals and global media headlines swarmed with speculation. Was it a block of solid hydrogen? Could it have been a debris? Or was it, as the esteemed Harvard astronomer Avi Loeb suggested, an artificial construction made by an intelligent extraterrestrial civilization? Whatever it is, one thing is for sure, it challenged our physics and baffled everyone. After reaching its closest point to the Sun, the object began exiting the solar system at very high speed, relative to our own Sun, or about 95,000 kilometers per second, more than enough to ensure it would escape our star's gravity. But, even with such a massive speed, it accelerated in a very smooth and steady manner, totally contrary to what is expected from a rough and irregular comet, during outgassing of its ices. The odds of such behavior from a naturally occurring comet is highly unlikely. By October 7, 2017, it was moving toward the Pegasus constellation, heading for points unknown. By then, with today's technology, there was no possible way to catch up with and photograph Oumuamua in close proximity. Thus, the data at hand is all that we will ever have. But all of its weird attributes could have one perfect explanation. Welcome to Lab 360, it's time to explore. Oumuamua might be an alien spacecraft with a light sail, a new study suggests. Indeed, an artificial origin would explain quite nicely the many weird characteristics of the cosmic visitor. Scientists initially regarded the object as a comet, but they reclassified it as an asteroid after observations failed to reveal a tail or fuzzy coma. But a team of researchers once again branded Oumuamua as a comet, after noticing that it displays non-gravitational acceleration. That brings us to the study, which Loeb conducted with lead author Shemuel Bialy, a postdoctoral at the ITC. Bialy and Loeb don't think the comet explanation holds up, because astronomers still haven't spotted a tail or coma around Oumuamua. There's another possible natural explanation, he added. If Oumuamua is just a fragment of a larger object, the observed motion could be from the kick that knocked that fragment loose. But such a kick would be a one-time thing, whereas Oumuamua has shown repeated, non-gravitational acceleration. So, Bialy and Loeb came up with a new hypothesis: sunlight may be responsible. In the new study, the duo determined that solar radiation pressure could cause the observed non-gravitational movement if Oumuamua is just 0.3 to 0.9 millimeters thick. What kind of structure could be so gossamer thin? Bialy and Loeb suggested one candidate, a light sail, which is designed to harness the momentum of photons as a propulsive force. Humanity has already demonstrated this tech in space. Japan's Ikaros probe successfully trekked to Venus's neighborhood in 2010. Bialy and Loeb further calculated that a light sail Oumuamua could probably survive a long interstellar trek. Given the concentration of gas and dust in the interstellar medium, and the speeds at which the object would encounter these deep space flecks, the researchers determined that Oumuamua could make it at least 16,000 light-years from its home system, whatever that may be, as Oumuamua's provenance remains a mystery. This is good news for SETI, Loeb said, referring to the search for extraterrestrial intelligence. This is not speculation, he added. It's evidence-based. We have an anomaly in the data. The anomaly is that the orbit deviates from a Keplerian orbit, deviates from what gravity alone would do. And the viable explanations for that do not exist, other than the one that we are proposing. To be clear, Bialy and Loeb aren't claiming in this study that Oumuamua is definitely an alien spacecraft. But they do think this is a real possibility. The object could be a piece of alien space junk, a defunct sailcraft that has accidentally found its way to us. Or it may be an active reconnaissance craft, sent here to check out our solar system, the researchers wrote in the study. There are reasons to favor the latter explanation, Loeb said. For starters, Oumuamua's very discovery was something of an anomaly. Our own solar system doesn't shed so many Oumuamua-like objects, he added. In addition, Oumuamua's motion is roughly coincident with the average motion of material in our patch of the Milky Way galaxy, a kinematic space known as the local standard of rest. Indeed, that's why the object's system of origin has been so hard to pin down. If I created an instrument whose identity I would like to hide, I would put it at the local standard of rest, Loeb said. Astronomers have used the Green Bank Telescope in West Virginia, and the Allen Telescope Array in Northern California, to listen for any possible pings coming from Oumuamua. To date, the object has remained silent. But regardless of what it is, the discovery is quite fascinating, a strange visitor from a faraway star system, shaped like nothing we've ever seen in our own solar system neighborhood. Here's hoping we spot another Oumuamua in the near future. What do you think Oumuamua is? Drop in your comments to let us know, and don't forget to subscribe to Lab 360, because together, we will explore.